Welcome to the 8th edition of the Brazil-Korea Forum. My name is Rodrigo Rigi, and I'm one of the coordinators of the Brazil-Korea Forum. On behalf of the Unicinos team, at this moment, I would like to thank Professor Aldebaro Jr., Professor Kleber Cardoso, and Professor J.P. Lee for accepting our invitation to participate in this event. So, Unicinos has elected South Korea as a strategic partner, so maintaining a partnership with dozens of institutions of that country for more than 10 years. In this way, the Brazil-Korea Forum is a traditional international event that celebrates the partnership of research, science, and innovation between the countries Brazil and Korea, together with other partners such as USA and Germany that have joined us during the last years. In this year, in particular, the Forum Brazil-Korea takes place entirely in a virtual way through a cluster of workstations and panels. So, at this moment, I would like to invite all the participants to watch a short video of the main achievements of the Brazil-Korea partnership.
Com sua primeira edição em 2011, o Fórum Brasil-Coreia consolida uma parceria de quase uma década entre Unicinos e instituições da Coreia do Sul, com o principal objetivo de compartilhar conhecimento entre pesquisadores na área da tecnologia. O evento estimula a inovação e desenvolvimento de produtos. Desde sua criação, o Fórum teve como principal tema a cadeia de semicondutores. A partir das relações criadas entre os países com o protagonismo da Unicinos, a área se consolidou com a instalação da empresa HT Micron no Tecnocinos. Ao longo dos anos, o Fórum possibilitou diversas oportunidades para a comunidade acadêmica, desde publicações científicas conjuntas, ações de mobilidade estudantil, dupla titulação na pós-graduação, projetos de pesquisa no âmbito da indústria 4.0, até a capacitação de recursos humanos para o setor tecnológico. As conquistas do Fórum Brasil-Coreia se ampliaram com o tempo e mudaram parte da matriz econômica da região. Além do estímulo às startups na área de saúde e tecnologia, o Fórum possibilitou a criação do Instituto Tecnológico de Semicondutores ITT Chip, a partir dos programas de pós-graduação em Engenharia Elétrica e Computação Aplicada. Em 2019, a integração entre pesquisadores brasileiros e coreanos, ITT Chip e HT Micron, criou um marco importante para a área no Brasil. Primeiro chip semicondutor para o mercado de internet das coisas projetado no país. Perspectiva de uma expansão e consolidação das suas relações internacionais, Unicinos mantém uma contínua ampliação do Fórum com a participação de países como Estados Unidos, Alemanha, Austrália, entre outros. Movimento estratégico que torna o pioneirismo uma tradição, fazendo da inovação uma cultura que a Unicinos, universidades brasileiras e coreanas, ter público e empresas constroem, agindo localmente e pensando globalmente.
So, again, welcome to the 8th edition of our Brazil-Korea Forum. So, for this afternoon here in Brazil, morning in US, right? Welcome again, Professor J.P. Lee and Professor Aldebaro and Professor Kleber. That's a pleasure for us to receive you in our university and in this event. So, as I said, we will have a panel, and in this moment, I would like to pass the token to Professor Cristiano Bot that will conduct with us this panel. Please, Professor Cristiano.
Thank you, Professor Rigi. It's a pleasure for me. Okay, I will start the panel 3, named Impact of the New 5G Communication Area in the Next Industrial Revolution. My name is Cristiano Bonat-Bot, and I am a professor of the Applied Computing Graduate Program in Siemens. I have a great pleasure to moderate this panel. Thank you, Professor Righi, for the opportunity. It's a fantastic moment. Firstly, I would like to thank our speakers. Welcome to 8th Forum Brasil-Korea, Professor Aldebarro, Professor Kleber, and Professor G.P. Lee. It's a fantastic moment for us. It's a great pleasure to receive and listen to you and our plan. Also, I would like to thank the people who are seeing us on YouTube. Thank you for our audience. Please, for any questions and comments, use the chat that I will read the questions and comments at the end of the presentation. Now, I will start our panel with the presentation for Professor Aldebarro. Professor Aldebarro received the PhD degree from the University of California at San Diego in 2003. And he is currently a full professor at the Federal University of Pará, Brazil, with an electronic engineering department. He is also a I2ET focal point and directs the 5G and IoT research groups at LACE. He is a senior member of IEEE, member of the Brazilian Communication Society, and a researcher of the CNPq and the INESC Brazil. Thank you, Professor Aldebarro. Please, the microphone is yours.
Thank you, Professor Cristiano. Thank you all the organizers from Unisinos for this opportunity. Cristiano, can you see my screen?
Yes, perfect.
Okay, so I'm going to talk about 5G for Industry 4.0 and emphasizing two aspects, the private networks and also new radio numerologies. And basically, we are going to start by asking why do we need 5G connectivity in Industry 4.0? Because basically industrial Ethernet is still the backbone of most factories. And the question is, are we going to replace this industrial Ethernet? And also, how about the other alternatives? How about LoRa, Sigfox? And specifically, what are the use cases for 5G in industry? And before I continue, I want to invite you to think that all this is about wireless connectivity. And if we look at wired connectivity, you're going to see field bus and the industrial Ethernet as being the most important solutions. And basically because they manage to work in very harsh environments regarding temperature, for example, humidity and vibration, also electromagnetic emission. And you see that field bus starts very early. So we have this kind of structure, and basically many of the PLCs today are connected by field buses. And besides, we also have industrial Ethernet. And if we look at the regular Ethernet, you can make a comparison between Wi-Fi and what we have, for example, now with 3GPP, 4G, and 5G that provide us quality of service. The industrial Ethernet is similar in the sense that it provides quality of service. It provides deterministic delivery. It decreases the latency. And because of that, if you look at the market share, you see that the industrial Ethernet right now has almost 60%. This is last year, 2018, so it was 52, and then in 2019, it was 59, with a growth of 20% that was before 22 and now 20%. And you see that there are many technologies inside this umbrella industrial Ethernet, as, for example, Profnet and so on. If you look at field bus, then you see that the growth decreased, but it still has a 35% share of this market. And then if you look at the wireless technology, you see a very small number, just 6%. But pay attention at this growth of 30%. And also for the first time, field bus declined this growth. So what we see now is basically industrial Ethernet increasing its market share and the field bus decreasing. And you look at the wireless, you see a very small share. But remember that we have a 30% predicted growth for the wireless technologies. And if you go on with predictions and look at this one from ABI Research, you see that the number of wireless connections is going to increase according to their prediction and then pass the wired new connections. So what's happening then in these factory environments? Why do people predict this huge increase in wireless connectivity? And it's not only because of 4G and 5G, but we have many other solutions. So if you look at, for example, low-powered wide area networks, you see many of these technologies like LoRa, Sigfox, and so on. And you still have Wi-Fi competing for some small markets because it's not providing quality of service. And the question then, if you look at the predictions, is are we going to have fragmented markets with many technologies, or 5G or beyond 5G like 6G and so on is going to take it all? And what I'm going to talk about a little later is how 5G people are trying to really provide the solutions for all the problems. If they are going to succeed, if we are going to see only 5G in future factories, then this is a question. But we do still strong 5G use case. So we can see that for some use case, 5G is the best option, especially when we are involving mobility and large bit rates. I'm going to talk about a few of these cases, providing you an example, because what we see is 5G is not going to replace what has been connecting, for example, PLCs or HMIs. The thing is that 5G is going to be used mostly for things that, as I mentioned, require mobility, as robots, autonomous, mobile, asset tracking, and smart glasses. And I believe that one example can show you. So this is a factory in ICE Mobility Company, and they partnership with Verizon, United States. And you see this guy, basically this is a object detection running, and these are the wireless cameras that can provide freedom or flexibility to change. And these are the antennas for these private kind of networks. And you see it can track everything, all the products put in the right boxes and so on. So this is a use case that's very strong for 5G and edge computing. And I'm going to talk specifically about two technologies that we are investigating at UFPA, the Federal University of Pará in Brazil, that I'm affiliated. So I'm going to talk about private and dedicated networks, and also about these flexible numerologies. That's part of the plan of 3GPP people to take the world and substitute all the wireless solutions by 5G. And we have many networks, and Professor Kleber is going to talk more about them. And just to indicate to you, we are going to be taking very specific examples of private networks. And also regarding numerology, the main issue here is, for example, decreasing latency. But we have many other technologies like edge computing and network slicing that also contribute to decreasing the latency. So just introducing you the lab that I work, we basically do telecommunications, electronics, and automation, and also machine learning. We have currently 4 professors and 18 graduates, like masters or PhD students, and 34 undergraduate students. We are located in this Park of Science and Technology in Pará, and we have this prototyping equipment and computers. So, but basically the main assets are the people. We have many dedicated students, and we put together some equipment that I'm going to show you to implement this campus network. Basically, the idea is that we have, for example, an antenna here providing connectivity, and then we fly drones, and we provide some extra surveillance technology to help decreasing, for example, problems with violence and so on campus. And we got this spectrum from Anatel, our Brazilian regulator, to provide this kind of coverage. So you see the circles here are 2 kilometers. So we can provide a very good coverage because this frequency is relatively low, and then the waves propagate more. So this is our Pagé campus network that we are building at UFPA. And the kind of equipment that we use is specified at the right. And this indicates to you the power of open source and software-defined radios on 5G. Basically, we have this centralized radio access network architecture where you have a radio remote unit that's closer to the antenna, and then to the right, you have the core network. And basically, all these functionalities are provided by network functions, and then you can put them or allocate in different computers. For example, you can have a controller for the software-defined networking elements in a computer, and then you have the core network running in another computer. And basically, these open sources facilitate to implement. We have open air interface from Eurocom and also free 5G-C from NCTU. And we also use Kubernetes and other kinds of software. But basically, this is just indicating to you the kind of equipment that can use to provide a private network. And then basically, what's this private? Also called non-public or campus network. If you look at this picture here that Professor Kleber is going to elaborate more, you see in red the public network, the conventional one that we basically use, and also the blue here is the non-public, when the company, for example, buys the equipment and can eventually run the network by itself. So many years ago, we started using, for example, Wi-Fi, and then now people can easily install Wi-Fi. That's what we expect for 5G and beyond 5G, is that people in future are going to be able to create a network for their company, and basically they may have an optional connection to public networks, but other than that, they can run their network. And they have many alternatives. For example, you can, instead of running by yourself, you can pay for some operator, like the ones that we have, and then they can provide the equipment, and then you start having some sort of hybrid kind of non-public network. And if you look at a commercial solution, you compare with the computers that I showed in the previous slides, basically what they have is a switch, and then this in black is a computer, like a personal computer, and then in white you have the radio, sorts of a base station. And this is all the equipment that you have to implement a private network. Why this is important for Industry 4.0? Because now people can effectively have quality of service, and they can control the systems by themselves if they want, or find some agreement with companies that can provide all the support. And what kind of market people predict? This is a prediction from Nokia. And if you look at the number of networks we have right now, this is 7 million. So this is basically owned by operators, okay? And what people are predicting is that industries such as transport, military bases or warehouse, industrial and manufacturing, oil and gas, and so on, they are going to sum up to twice this number, 14 million networks. Only in industrial and manufacturing that's of interest today, they are predicting these 10 million networks. And you can see this is huge, and maybe it's not going to be true. This number may be, let's say, a large number, too large. But if you compare with what people already have, you can see that private networks are going to have a big impact. So I took some public networks here from Shell and etc., and some private networks, 5G private networks from Airbus and so on, and hybrids. So we should expect to have this number of private networks increasing. And to get an example, I took from this study here that's basically made by Ericsson and ABI Research. So they look at many factors, and this one is a South Korean automotive factory. And they compared what they call status quo in reds. That's basically the way people are running connectivity right now, let's say using wired connections, and with the cellular connected factory. And they did this technical techno-economic analysis to predict that if you move from this current status quo to a cellular connected, the profitability of your business, how much money you make, is going to increase. And they have numbers such as 5% to 13%. So this is a huge point because, of course, if you can make more money, you can have more flexibility, for example, changing the position of the robots, etc. Then people are going to embrace this aspect of using more 4G and 5G. And talking about now the physical layer, preparing to the second kind of technical topic that I want to mention, that's the numerology. We know that 5G has a new radio, so they call NR. And basically, one of the capabilities of this new radio is to decrease the latency that was around 30 milliseconds for 4G to up to 1 millisecond, for example, for 5G. And they have also increased the bit rate and so on. But looking at especially the latency, we can see that it's important because if you look at this kind of KPI, key performance indicators, we note that for factories, you need very small latency. That's basically the time the information takes to go from the transmitter to the receiver and come back. And also, you have to have a small block error rate that's related to the bit error rates. And you see that whenever you design a radio, you have to take in account all this, but also some other aspects, because some people want just to navigate, just to surf with high speeds, and other people want to use many IoT devices. So they put together these three classes of use case. And now I'm going to talk how new radio can try to address all the potential use cases here. And basically, this is the numerology. What they did is they made more flexible. They tried to create a radio that can work in most of the environments. And they, besides using different numerologies, 5G has what they call bandwidth parts that allows you to flexibly split the spectrum. So if you look at the left here, basically all the radio frames, they need to be transmitted continuously, for example, every 10 milliseconds. And then if you go down, decreasing from radio frame to subframes to slots, you see what people call the time frequency resource grid. In 5G, you're going to have more flexibility, but in 4G, you basically had one resource here represents the square, and then you concatenate many of them to create a resource block. But if you compare with 5G, you can have a different strategy, because in the x-axis, this is time. And what 5G allows you is to have a longer time if you want to, for example, increase the bandwidth. But it also allows you to have a shorter time. If you compare this table, that's why they call numerologists, because they have many numbers here, but you can pay attention only on this slot length. And LT is basically this first option, and it was fixed. You basically had only one small alternative or different alternative from this one, but 5G has many more. And what you see is they decrease the slot length, basically by providing this numerology in different bandwidths and also with extra flexibility. So what's the lesson? This is what we do at UFPA. Basically, we want to benefit from this flexibility. And what you see at the left are different users. For example, massive type of communications or broadband transmission, like a high quality video, and drones, and also robots. So if you have all this flexibility with the new radio from 5G, what we want to do is, if this robot needs a very short latency, then you send through this bandwidth part, the blue one. But if you need some, for example, high bandwidth, maybe use this yellow alternative, or the green one for people that are just navigating. And then if you combine all this flexibility, you get what I'm going to try to show in these slides. Basically, I try to bring a visual experiment, something that you can see. And if you look at this drone, basically what we are trying to do is to keep the drone at some height and then put it higher. This is indicated in this graph. So you put at some position and then you ask to move to the top. And this is the regular network. But if you add extra latency, so extra 200 milliseconds of latency, basically this is the same experiment. So we just wanted to make the drone stop still, but you can see this extra latency doesn't allow it. And basically, this is what you see in robots. If you go to a factory and you increase the latency, this is the effect that you are going to find. You cannot stop the drone like still this way, but basically it's just moving around because of the latency. And we are using some simple control technology like PI. And basically you can imagine in a very complicated environment, all the kind of sophisticated controls having troubles to keep up, for example, with the performance they have because of the latency. And this is the importance of having right technology, and that's what 5G is trying to address. They are using this very flexible radio to decrease technology. They are gonna, of course, increment with technologies such as, for example, edge computing and so on. But I tried to bring you an example why 5G is being prepared and it's ready to control robots and etc. And this is the graph that we get when we have, for example, the correct networking in blue. So it have is smooth. And then if you have an extra latency, you can have this kind of peak, basically because of the latency, the control doesn't work more. But the take-home message here is that there are important use cases for 5G based on mobility and large bit rates. And 5G is going to be there in Industry 4.0 for sure because of that. That basically concludes my talk. And I thank you again for this opportunity and pass to Cristiano again the token. Thank you.
Thank you, Professor De Barro, for your excellent talk. It's a fantastic point of view. I agree, completely agree for your point of view. Thank you very much. The next talk, we will heard the Professor Kleber. Professor Kleber is an associate professor at the Institute of Informatics in the Federal University of Goiás. He has received the PG degree in 2009 in electrical engineering from Federal University of Rio de Janeiro. And 2015, he completed his first sabbatical in Virginia Tech in USA. And now, in this year, he started his second sabbatical in INRIA Research Center in French. Professor Kleber has participated in some international research projects, including two from Joint Call Brazil Europe, and coordinated many national sponsor research and deployment projects. His research is focused on wireless networks, software-defined networks, virtualization, resource allocation, and performance evaluation. Kleber, thank you very much. The microphone is yours.
Thank you, Cristiano. Can you hear me?
Yes, perfect.
And the slides, can you see?
See, yes.
Thank you. So I want to thank you again, and also Professor Hig. I also want to thank you, Unicinos. You are not hearing me?
Yes, I can.
Okay, because I receive a feedback here that you are not listening to me. I'm sorry. So come back again. So I want to thank you, all you, including the institution. I want to also congratulate Unicinos and all the other institutions involved in this initiative. I think it's a very important initiative, the Brazil-Korea Forum. So in this presentation, I'll talk about 5G software, mainly in the context of Industry 4.0. I will enjoy the overlapping with the presentation of Professor Aldebarro and use some of the concepts that he already introduced. Well, I want to start my talk with a statement made by the chair from 3GPP by the end of December of 2019. In this statement, he said that 5G is considered for 3GPP a starting point for evolving mobile networks in order to transform them as a platform for verticals in order they can deploy their services. This also means that the influence of these verticals will affect practically all levels of 3GPP. But what exactly means verticals for 3GPP? Well, there are lots of different verticals, but one of them, which appear in the top of the list, are the factors of the future, or fourth industrial revolution, or simply Industry 4.0. And why this opinion is important from my point of view? Well, 3GPP is one of the most important organization in the standardization. So I think this statement has a lot of impact on how 5G networks will be developed. But actually, this idea of having Industry 4.0 as an important subject comes even before this statement. Back in 2012, when ITU, the International Telecommunication Union, defined the IMT 2020, they come up with these three major scenarios. They have already been described by Professor Aldebarro, so I use the information he presented. I want to highlight that the Industry 4.0 actually belongs to two of these scenarios. I think that the most related one is ultra-reliable low-latency communications, but Industry 4.0 also demands some characteristics of evolved mobile broadband. If you take a look in this picture in the bottom part of the slide, we can see in these red circles some of the KPIs or some of the requirements expect to be satisfied in order to attend the services or applications related to Industry 4.0. So we can see that Industry 4.0 needs mobility, needs also high data rate, and of course, it depends a lot on latency. This orange box also highlights some numbers that are very interesting to take a look. For example, in Industry 4.0, we can have scenarios or use case in which the availability can be 5.9 or even 7.9. So this means a time between failure of near 10 years, which is incredibly high. The latency, of course, is expected to be very low in most of the applications of Industry 4.0, in general below 1 millisecond. The speed can go up to near 70 kilometers per hour, and the bit rate can be 500 megabits or even more per second. And well, so what we could expect is that 5G networks introduced a lot of new technology for Industry 4.0. Actually, some of this technology has been introduced by 3GPP even before 5G. For example, LTE-M in narrowband IoT has been introduced in release 13. But most of the interesting topics and technology has been introduced starting from the release 15, which actually is also the main milestone for 5G. I highlight the main topics according to FreeGPP related to Industry 4.0, which are TSN and TSC support, NPN, and 5G LAN type service. I'll talk about a little bit about all these topics. I also add two other ones that I think are important in this context. First is the 5G core, which is incredibly important in the context of softwareization for 5G networks. And the other topic is non-FreeGPP support, which is also relevant in this context and is also part of my research. Of course, there are lots of other interesting topics to talk about, but I think we don't have time to talk about them. But I list some of them here, such as artificial intelligence, machine learning, MAC, network slicing. This only to talk about software, because of course there are a lot of new technology related to hardware and related to both of them. Some of these innovations involve both hardware and software. For example, NPN and TSN and TSC support. So let's start with the core. As I said, is an element that is key in this context and actually act as a basis for other topics here in this presentation. I think a good start point for talking about the 5G core is putting the 5G core side by side with the 4G EPC, which is the core for a 5G network. The first thing that we realize is the number of elements or components that we see here. Actually, in the 5G core, we name them as functions. So this larger number appears in order to provide more modularity. So what is happening here is some elements such as the MME that accumulate several tasks now divide these tasks into other functions such as AMF, SMF, and AUSF. This also means flexibility. Since we can change one or other of these functions, we can introduce new functions and we don't affect the rest of the system. We have also new functions. You see here in the left figure, we have two functions, the NSSF and the NWDAF. These two functions add completely new service related to slicing and related to analytics. This does not exist in 4G. And other interesting thing that we can see in this figure, in these two figures actually, is the service-based architecture, which only appears, of course, in the left, because in the right, we don't have this concept introduced yet. This concept is very important because it brings one of the most relevant contributions from cloud computing to the context of 5G. And this is very important to achieve scalability. Also comes from the cloud computing context, we have the idea of service-based interface. This is very important to facilitate the integration with other software, other sets outside the context of the core. So the integration now becomes easier because in general, the application use technology such as HTTP REST API, in which is based the new 5G core. Well, actually, the service-based architecture is very important, but we still have a lot of reference points, which means there's a lot of tangled lines here that represent the communications among all these functions. As we expect, since we have more functions, we have more reference points. And we have an issue here, how we can coordinate or inform to one function to find another function and consume services from that function. This is a very important concept in the new core because we have the opportunity to add new functions, we can change functions. So this is a very dynamic environment. So we need, in some sense, to make this architecture flexible. Then we have something that comes also together with the service-based architecture. That is the concept of service discovery. Active service discovery involves service registration and service access. Here we have a very simple example in which the AMF is a very important function in the core. It's related to access and mobility, which is some very basic in a mobile cellular network. And let's assume that this function needs to contact PCF. It's a function related to policy control, generally related to security and also QoS policies. So in this example, at some point in time, the PCF needs to register with NRF. NRF is another critical function in this SBA, because this function is the only one that all other function needs to know. Because if this NRF, which means network repository function, all other functions can find information about different functions that they need to consume services. So, as I said, in some point in time, one or more than one PCF start registration. It means put information about how can be achieved and what type of service this function offer. After this, at any time, any point in time, another function, for example, an AMF can discover service by only contacting the NRF and search for matching NFs. In this case, the AMF is searching for a PCF that matches the criteria. And after getting the one that satisfies, it now can finally establish the reference point, because now it has all the information to get in touch with the PCF. So this is quite simple, but it's a pillar for the SBA. Well, another topic that I comment that is very important, included from the point of view of FreeGPP, is the support for time-sensitive. Time-sensitive has an important set of specifications from IEEE, named as IEEE TSN, which the idea is basically provide the deterministic and low latency communication for factors of the future. And what the 5G network is introducing is the time-sensitive communication, in which the idea is to integrate a 5G network with a network or a set of networks using IEEE TSN. So with this integration, a 5G network can provide high reliability and availability for deterministic and isocronous communications. Actually, this is not a great challenge for a mobile cellular network, since this time-sensitive in general is something quite common in this network. But of course, there are some interface points that I will show in the next slide. But before that, let's just list what we mean by high reliability and availability. First, 5G TSC is expected to provide packet transport with QoS, which means bounded latency and reliability, and also to provide to the end system and relay transmit node strictly synchronized service. Actually, what we are saying in some sense is that we can change a 5G network into a time-sensitive system, which appears for the other IEEE TSNs as another TSN also. So we can integrate multiple TSN using 5G TSC network. So what are these points of integration? They are critical in this concept. So what we see here in this large rectangle is a 5G network, a whole 5G network. We have some blocks in the top, which represent the core, UDM, NEF, AMF, SMF, and PCF are all related to the control plane of 5G network. And you can see here an integration of a new application, the TSN AF. So it's a TSN application function that in this case is designed to interact with the 5G network in order to provide the necessary information for these two yellow points. These two yellow points that are named translators. We have two types of translator here. One for the device side that interacts with the TSN system, and one for the network side that interact with another TSN system. UPF is part of the core also, but is related to the user plane. And we have also in this figure represent a RAN, a radio access, or actually it's not necessary radio, can be another technology, access technology, but in general it will be radio in order to be wireless. And we have user equipment. User equipment is not part of the core, is not part of the RAN, is a mobile device. And you can see here, and you can put this mobile device together with the device side, and these two work together, create this concept of device side of bridge. So this allows us to create this concept that the whole network becomes a layer 2 IEEE 802.1 network. Another topic that also was covered by Professor Aldebarro, it is the private network. So I will be very brief in some points, and I will try to highlight some parts that was not covered by him. In this non-public network, we can separate them in two groups: the standalone non-public network and the public network integrated NPN, or we simply call PNI NPN. The idea is, in the left side, we have those type of networks that have all the infrastructure provided by the company, in this case, the industry, using a 5G network. As you can see here, let me briefly describe what means these icons. So we have 4 icons here. The first one, this cylinder, represents the subscriber database. The second one is the control part of the core. So it's the core, but only the control functions. This third one is the UPF, is the user plane function. So it's also core, but it's related to user plane. And finally, the services. These antennas represent a radio access. So as you can see here, all this is replicated inside the industry, inside the infrastructure of the industry. And if the industry has interest, it can connect to the public network. But this connection is optional. In the public side, we have a range of options. In the presentation of Professor Aldebarro, he described for us the deployment with shared RAN. I'll give more details about this last one. I think it's another interesting scenario to describe. What changes here, this range of options, is what we are keeping inside and what we are using in a shared mode. So in this first scenario, what we have is just sharing of the RAN. The other elements is still replicated inside the industry network. When you go to the deployment with shared RAN and control plane, now the control plane and the subscribed database can be shared with the public network. And when you go to this last scenario, everything is shared, but the services, only the services are really kept on the premises of the industry. Everything else can be borrowed or leased from a public network. I will not give many details, but I'll show in a slide later that the key here is network slicing. Probably some of you are already aware of that. So just to put more details here, I will not go in very detail, but I think this figure gives a more clear view of what I was describing. So this is the extreme left scenario. We have all the elements here, the RAN, the user plane function, the control plane function. This is all about the core, and you have the assets of the industry connected to this 5G network. And we have in this right all the public network, complete isolated from the private network. And here we have that the extremely left scenario in which we have all the resource, as you can see, belong to the public network. In this blue appearing in the slide, in the bottom of the slide, we have the what we can call the physical. I'll not call physical because actually here we are labeled already with the public slice. So this is part of the physical one, but using for public use. It means that the base station, the UPF, the MAC, the core here are used for a public use, so can be used for different companies, different people. But over this infrastructure, this physical infrastructure, we have another slice, which is the private slice. As you can see here, everything comes from the public network, but now it's leased to this private company, to this enterprise, for example, an industry for using. The only things that are not belong to the public are the consumers of this slice, which means the LAN and the device connected to this slice. And the first top, very important from the point of view of 3GPP, is 5G LAN type service. Actually, this is very common for any administrator of network in general, any team that has to manage a network or infrastructure of communication needs to create virtual LANs or virtual private networks. So this is the way that the 5G is offering these services in a 5G network. What is interesting to highlight is even the concept is quite simple. The idea is having, for example, virtual network groups and put identifiers and add and delete members. Members in this case are user equipment to these virtual network groups. But what it's necessary to provide these VLANs or these VPNs over a 5G network, it's quite sophisticated because we are talking about a large network, we talk about a mobile network, and all of these must be hidden from those who are using the 5G LAN type service. For those who are familiar with SDN, probably will see that is basically SDN concepts, because what we have here are the UPF. UPF is the user plane function, but we can see as a virtual switch or a programmable forwarding device, which is controlled by a controller, in this case, the SMF, the session management function. So it's this function that can be used from an administrator, for example, to put rules in order to create this blue virtual network group, or can be dynamically created by an application using SBI, the service-based interface, in order to dynamically create, for example, this red virtual network group. So it's a quite simple concept, but it demanded a lot of details in order to be properly implemented in a 5G network. So now going to another topic, but I think it's quite relevant in this context. Actually, Professor Aldebarro has already tackled this topic also, is the support for other technologies that are not FreeGPP, what is called non-FreeGPP support. Originally, the idea is giving support for WLAN or Wi-Fi. These appear even in 5G networks, but in 4G networks, but in 5G networks, this has been improved a lot, and it's much more sophisticated. And in 5G, they also add the support for wireline. As an example of wireline technology is DOCSIS, also known as HFC or cable modem technology. So there are two parts related to non-FreeGPP support. One is described in release 15 from FreeGPP, is called untrusted, and the other is called trusted. The untrusted, which is illustrated in this picture below, we have a function called N-free-IWS or non-FreeGPP internetwork function. This element allows us to connect a device, for example, an access point, an Wi-Fi access point, through a reference point called Y2. This is not really relevant. It can be a cable, for example, the internet, it doesn't matter. And then this allows that users can connect, for example, using wireless Wi-Fi, and then establish a security channel, this NWU. So this is critical in this concept because the NWU must be a security channel. So after this channel is established, now we can establish a traditional signaling, which is this NU1. So through this NU1, a user can start a non-FreeGPP user can start using a FreeGPP network, in this case, a 5G network. The trusted non-FreeGPP support is more sophisticated, has been introduced more recently, but it also has some drawbacks because it depends, for example, in a trusted non-FreeGPP access point. And this is not very clear how we can effectively trust on this TNAP, but the fact is, once this TNAP exists, now we substitute the N-free-IWF for the TNGF, is a trusted non-FreeGPP gateway function, and these two create a concept similar to a base station, a classical base station, in which you have the reference points N2 and N3, and now we can send the signal N1 through them. We have here a tunnel, the NWT, but since now our AP, our access point is trustable, this tunnel can use a non-encrypted channel, so it's just a tunneling for more basic signaling. There is no security concern since everything is considered trusted. But a point that it was very clear from Professor Aldebarro is about in the other technology. We're talking about Wi-Fi. We said that we give support to DOCSIS, but what about LoRa, Zigbee, Bluetooth Low Energy, and so on and so forth? Well, the standards made no discussion about. There is no clear answer for that, but everything is about software here. And so we can use this flexibility of the 5G core in order to provide. This is something that we have been working recently. Here I have in this picture below a summary of the ideas that we have been developing, which basically consists on using the N-free IWF and connect to this a gateway. In this example, I'm talking about LoRaWAN, but we could employ this idea to other technology. So in this gateway, in this case, the LoRa gateway, we add a software piece, user equipment. We are calling UE IoT non-free GPP. And then, I don't know if you remember, but we have in the previous slide this Y1. Here we create a sort of logical loop in this Y1, so we can establish now the tunnel not from the device, because the device here, a LoRa device in general, is very simple, is not able to create the signal necessary for establish this tunnel. So we start the tunnel from the gateway, and then we can now, with this NW tunnel, start all the N1 signaling in order to communicate properly with this network. And through this tunnel also, we can reach the user plan function, and so we can reach other elements that are part of a LoRaWAN network, such as the network server and the application server. And here we also illustrate how this service can interact directly with the core in a proper manner, using the application function, and also use the NEF. I didn't explain, but NEF is very common also when you talk about external service, because it controls the access to other functions that may be very sensitive to the network. So we have the network exposure function that works as a proxy for other functions. And to end my presentation, I want to comment very briefly about this initiative, which are naming My 5G Initiative. Is initiative that involves myself and several other colleagues. And the focus is developing open source software in order to have modular and easy software to deploy and operate. Not only for network operators, but also for other companies such as industries. And this initiative, we have a lot of interest, of course, in the core, that, as I said, is a key element in this softwareization concept. But we have been working with IoT, a tester for 5G. We are starting implementing and emulating the new base station, the GNB, and also the user equipment. So that's all. Thanks again, and I return to you, Cristiano.
Thank you. Your presentation was wonderful. I agree completely. And your point of view is perfect for me. It's very technical, but it's very interesting. Now we will listen to Professor G.P. Lee. Professor G.P. Lee is a professor at the University of California in Irvine, with appointments in 3 departments: electronic engineering and computer science, chemical engineer and material science, biomedical engineer. He also served as director of California Institute for Telecommunications and Information Technologies in his university, and director of the Integration Nanosystem Research Facilities in the Henry Samueli School of Engineering. Professor Lee holds 38 US patents, and he has more 12 patents pending. He has one of 4 engineer professor honored in his university, considering significant contributions as inventor and creator in 2005. Professor Lee, thank you very much. Please talk about your future and smart manufacturing for sustainable growth.
Thank you. Can you hear me?
Yes, perfect.
Yes. Before I start today's, I'd like to take this opportunity to thank the organization committee for inviting me to present my topic of future of smart manufacturing for sustainable growth. I also would like to thank the audience for listening about my talk.
Professor, sorry, I didn't see your slides.
You cannot see the slide?
No.
Can you see the slide now?
Yes, I can. Perfect.
Perfect.
So you have listened to the previous two talks and really highlight the need of 5G for the advanced manufacturing. So what I try to do here is giving you a very brief overview of industrial revolution from the 18th to the 21st centuries of four major industrial revolutions change how we do manufacturing. As you may recall, in 1782, we created the steam engine, and that is the first industrial revolution to improve the quality of life through the engineering science. And the second industrial revolution is really in the beginning of the 20th century, and to bring the mobility to the mass. And this is through the use of the conveyor belt by Ford Motors, as well as Edison, to introduce electricity everywhere so that we can be very efficiently produce those mobile devices and bring mobility to everyone. And the third industrial revolution is really about the automation controls through the use of electronic automation. And most of the connectivity was done by wire-connected devices. And with this microelectronic and automation control, we were able to really improve the manufacturing efficiencies. And now we come to the 21st century, is really relying on the cyber physical system. It's so-called the utilizing the information communication technology, entering the fourth industrial revolution, is also known as the 4.0 revolution, and it's about the smart automations. And so not only the wire connectivity, but also wireless connectivity to the cloud allow the intelligence to be available at the edge. So to convince you how this industrial revolution will change the society, shown here is at the dawn of the 20th century, 1900s, on the street of New York City, you can only see one automobile. Within 10 years, on the street of New York City, you can only see one horse carriage. What I try to say here is think about the 5G wireless communication. It's like the carrier, which much higher speed, lower latency, and larger bandwidth is going to transform the society, very similar to what we have witnessed to bring the mobility to majority of people. So now, before we talk about gas emission, namely CO2 and other greenhouse gases, and that also shown here is the consumption by fuel in million tons oil equivalents for different sectors. So what you can see here is the power and industry use contribute to the most. Now we are fighting the climate change. One thing we need to really worry about is how do we reduce the energy consumption, and which is also very critical for manufacturing, because electricity is a bill material. The less energy used to produce the parts, the more profit you are able to gain. And the second challenge we see is in today, we see is workers, now they have some form of connectivity, say Wi-Fi or local area network. But what you can see here is at the same time, we have heard so many talk about the robotic is going to move into the future manufacturing, and robot is going to really replace human being. So the manufacturer worker worry about losing in the battle against the machines. So this is also a challenging in the future manufacturing. How do we deal with that? And what we have to remind ourselves, the smart workers' asset is the brain. People is the optimum manufacturing asset because human has a very sophisticated onboard sensor. We have a 5 sense plus common sense, and we have the ability to learn, think, and adapt, and has a powerful pattern recognition. And most importantly, human being is excellent for contextual awareness, which is not readily done by any AI machine. So how do we really combine the content awareness for the IoT, cyber physical system, with contextual awareness information together as a way to improve the manufacturing productivity? That is the one we need to think about. And the last piece is about the greenhouse gas emission by economic sectors. What you can see here is electricity productions, industrial, and agriculture. They contribute to most of the greenhouse gas emission, and also the waste in manufacturing industry due to the overproduction, transporting, and the inventory defects, and so on. So they consume those unnecessary resources and also contribute to the greenhouse gas emissions. So with that, we have to ask ourselves, while we are able to harness the profits from producing goods, we have to think about the future in the 21st century to have a sustainable growth, demand smart manufacturing. So the sustainability is a fundamental about people's ambition for their community today and into the future. Making this vision operational require operating with a balance of forces that drive process with respect to the economy, the environment, and the society. So we have to really think about the balance of the forces, profits, environments, and people, the society. So in the smart manufacturing, we have to think about is a smart manufacturing operation to have high efficiency, lower the production cost. The second thing is we need to have a smart workforce for manufacturing. They are able to adopt the change and adopt the new knowledge so that they can continue evolve and advance their career while working in manufacturing sectors. And last piece is we have to come up with a smart manufacturing engineering for sustainable environments to deal with the climate change. So those are the three major things when we think about the future smart manufacturing. So how do we do that for the smart manufacturing? And typical, this is known as a data-driven knowledge for manufacturing industry. The first one is in the automation control is a computation to have way to define the values. And through the digitization, we have a computation and connectivity in automation control. In third generation of industrial revolutions, connectivity was done by wire connectivity. And in the fourth generation of industrial revolution, this connectivity will be done with 4G and 5G. And very likely 5G will be the one to take over this major work in connectivity. So with this tool as a foundation of a digitization of manufacturing, when we move into the Industry 4.0, utilizing those data, we try to see is visibility. What's happening? By having the data, we see the visibility, we have the visibility of the operations. Then we try to understand what is happening with those data, why the data behave in such a way. And then with that understanding, we try to provide the answers. What will happen is being prepared is a predictive capability in Industry 4.0. And last piece is how can an autonomous response be achieved? So this is really self-optimizing. So it's really system level holistic approach in smart manufacturing. So in the 5G is dealing with the first two parts in the digitization process, but with the distributed 5G network, a lot of resources will be available to allow this to happen. And this is what we can think about. So this is a current project I'm working on is future smart manufacturing. This is the vision developed by Smart Manufacturing Leadership Council. So it consists of 3 major parts. One is connected supply chain. And we need to have the agile system, and is a demand driven and raw material to finish a product. So in this way, we are dealing with is on demand to supply the needed material to reduce the waste. And this is really about the supply chain management. And this is the smart factory, typical IoT solutions. And you could have a visibility about the machine status and to do preventive maintenance and to also improve the energy efficiency to reduce the unnecessary waste in the manufacturing. At the same time, because of the visibility of the worker machine interaction, there is a sort of a safe protection, improve the safety and fewer incidents and more user-friendly environments. And in order to deal with this sustainable growth in terms of manufacturing environment for the energy supply, it will be more renewable green energy to be available to manufacturing environments. And when we are dealing with renewable energy, such as the solar or wind, they are intermittent energy sources. So how do you do dynamic control in manufacturing process utilizing those renewable energy? That is some kind of really a dynamic control require some kind of latency, low latency solution. 5G is the one to meet their requirements so that we can have a better energy efficiency, lower the emissions, less energy use, and is a green manufacturing process. By the time we're done with the manufacturing and it goes through the supply chain, this is really about how we can really be efficient to have a distribution center and warehouse to deliver the good to the needed customers. So this is a higher value product and data for decision making and the product lifecycle management so that we can really substantially reduce unnecessary waste. And the entire process can be optimized. So it's asset utilization of zero downtime and quality and zero defect and reliable results. So this is the entire smart manufacturing infrastructures, but more importantly, human, the future smart worker should be in the loop and they can intervene, interact in every step and require some level of mobility. And 5G, the mobile wireless communication infrastructure, is going to provide this fully integrated smart manufacturing in the futures. So how do we support that? This is an emerging technology, smart wireless cyber physical system, namely empowered by the 5G. So what is the wireless cyber physical system? How does it work? So I'm making a human analogy to this wireless cyber physical system. For human, we have a 5 sense. And for example, I try to grab a glass of water. So what is the actions? My hand is moving towards the glass, and my eye is looking at my hand movements and send a signal through my central nerve system. And then my brain is doing the computation and send a command to ask my hand to move further to grab. Then when I touch the glass, and the sensor will send back the information about how much pressure I put onto the glass and send back the feedback signals. So this is the typical human analogy for the edge device sensing. And the central nervous system is about the backbone communication in 5G. Allow this information to flow freely, and the cloud is our brain, the cloud is a computation. And with a distributed network, we can have not only the brain functioning, but also the muscle can have edge intelligence. So the whole thing, we are making this wireless cyber-physical system very similar to human activity. And as you know, humans' activity is very efficient because we have built in those edge intelligence and how we can processing the information in a way that intelligence can be continue and carry on. So what is the 5G? As previous two speakers already talked about, it has three major characteristics: high speed, low latency, less than a millisecond, and it has a massive scale for the massive IoT communications. So this is a perfect solution for this wireless cyber-physical systems. And to convince you as users without being working in the manufacturing floor, shown here is a comparison of the 5G versus 4G and 3G. For 3G, it would take about 26 hours to download the 2 hours long movie, Guardians of the Galaxy. This is flying from New York to Sydney, including layover in London. When we come to the 5G, for the same 2 hours movie, the download will only take about 3.6 seconds. So this really tells you what is a massive capability at your hand to conduct the future smart manufacturing. And so the 5G characteristic is having a very small cells as presented by the previous two speakers. So in US, for the private network, what we have here is using the typical light post. On the top of the light post, you have the antenna, and also already have existing power supply, and also the network control and local processing. So this is a way now you can imagine the use of a 5G because it is a dual band solution, 3 to 6 gigahertz, and other ones 26 to 28 gigahertz. So almost every 200 meters, you will see a 5G base stations. And inside the manufacturing floor, you could have a private 5G hub network. So in addition to the backbone 5G communication network, what we have seen is over the years, there were more and more computation resources to peoples. Showing here how the number of computers available to the user. And when we enter in 2020, what we can see is almost everyone carry more than 20 computation resources, the microprocessor, microcontroller, and so on. So there is great confluence of efforts to bring the wireless internet of a complementary system with the existing network. So now we have a way to really bring the human and thing at the intelligent edge to interact with the environment, so we can really create intelligent environment to really support our goal, have a sustainable growth and fighting the climate change. So as I just say, how do we do that to bring the intelligent edge to the workers? Showing here is one example. Imagine now with the 5G availability in your factory, now the worker can have this is a typical helmet to protect the safety of the workers. And now you could have additional sensor to see those infrared, which human eye cannot see, or you can hear the very low frequency noise or very high pitch noise, and usually human ear cannot hear them. And now you have this complementary sensor to bring wellness to the worker. And not only that, because of the edge computation resources together with the 5G, now you are able to bring the wireless intelligence, wireless AI to the people, to the worker, So now they can make intelligent decision. And what you can see here, because of all the wireless connectivity with a location finder, you can really ensure the safety of the worker inside the factory floor. So what I just show you is really coming up with a mobile adaptive evolution platform for smart manufacturing. It has a feature of a high touch, interactive, and personalized needs. So what I'm proposing here, we are working on is really a human-centric service wireless edge devices. It interface with IoT devices to the different machine with a sensor, controller, actuator, and effectors, and also interact with the supply chain and delivery. And this worker, because a human is a mobile sensor, so because we have the 5 sense, we can also collect the information through the human interaction, which is not readily available by using those IoT sensors. So it really is a confluence of integration of human environments and machine all together. Information is going to be communicated through the 5G network, and if there is a need for developing the intelligence and doing the computation work as is a cloud service, then this is going back to the mobile actionable intelligence for individual so that they can act upon these recommended solutions. So this is a one control loop for the optimization of manufacturing. But for the workers, this is a second loop because of this learning process, smart decision-making support through of this entire network. Now the worker can upgrade their knowledge, and this upgrade of the knowledge can be fed back to this control system. So basically, we are creating a system allow the worker to adapt to the change and upgrade their knowledge while they are able to apply their new knowledge to solve the problem. It can also enhance the optimization of this manufacturing process. So how do we deal with this edge device? This is a human-centric service wireless edge. So what we have here is all the IoT devices and connection to the supply chain and delivery. So the analogy of the edge device is basically the center part is you have to have the reconfigurable analog front end to take the data from the sensors, actuators, and controller, and so on. Then you have the local edge processing microcontroller, microprocessor, and the radio to connect to the 5G. And also you need to have a local, really a low power consumption devices with the battery and or to have energy harvesting so that this kind of edge devices can be wearable and can be mobile following the humans, workers, so that this can collect the information in time stamp and location stamp informations. And has to be extremely low power. And this is the human-centric edge device. So with this one, from the Internet of Things of IoT to the Internet of a smart worker for happy, safe, working, healthy environment. So the industrial IoT with the AI bring the high-value solution to optimize the production, improve efficiency, and preventive maintenance. But with the Internet of a smart worker, with augmented intelligence using the 5G as the medium to support that, we will be able to optimize entire workflow and improve the energy efficiency and reduce the waste and lowering the GHG emission, because this industrial IoT doesn't do the workflow, doesn't know what that means between the interaction human, worker, and machine and environments. So this is really the optimum system, and to empower that, 5G is the key. So what you can see here, while we're moving into 2030, by then we predict to have a 10 trillion sensor to be used everywhere for manufacturing, for the environments, for the people, and so on. So this is tons of data will be processed and need to be also communicate in a mobile sense. So what we see here is the future of data engineering empowered by 5G, because we will have this mobile intelligence, and that mobile intelligence is empowered by 5G, and the data is the new oil. We need to find it, extract it, refine it, distribute it, and monetize it without polluting society. When I say polluting society, it means we have to really be concerned with the person's privacy and security. And 5G is a path to really drive the future growth through the data engineering, mobile data engineering. So in summary, with the 5G, a worker-centric wireless cyber-physical system can be designed and implemented, empowering data-enabled smart manufacturing, energy efficiency, low greenhouse gas emission and waste, adaptive learning for sustainable growth, while advanced manufacturing is used as an example application, combining IoT edge device with a 5G communication and future 3D integration technology for edge intelligence will empower smart service and represent opportunity for future growth. I don't have the time to talk about the work we are doing is how we really create the sort of edge stack device, 3D integration to really make this a form factor small enough and can be truly mobile, available to all the workers. So at this time, I think it's maybe majority of you have not visited UCI, except George. He had a sabbatical with us. So UCI is about 45 miles from the LA airports. And this is, we are about 20 miles from Disneyland, the first Disneyland. And in the winter time, not like right now, in the morning you can go to the mountain. It's about 1.5 hour drive to do the ski trip. And in the afternoon, you can come to the Newport Beach to do surfing. And then now you can go to Disneyland to enjoy the scene. So this is really happiest place on earth in Orange County. So when you have time, please come to visit us. So I welcome opportunity for collaboration. Thank you.
Thank you, Professor Lee. Fantastic presentation. I agree, and the opportunity is fantastic for deploy other solutions. Thank you very much. And now we start one time for the question and the answers. More or less, we have more 20 minutes, and why I have question in the YouTube chat. And the first questions, the Professor Lucio at Unicinos asked, in our view, will this convergence provided by 5G technologies replace other technologies, for example, Wi-Fi and other LPWAN, such as LoRaWAN and Sigfox, or create one environment of coexistence? My suggestions are answer in our round. For example, we start in the Aldebarros, next the Kleber, and finally the Professor Lee. The question about the coexistence considering the different technologies.
Okay. Then I can say that, well, people at 3GPP, what they want is clearly to make the 5G technology the solution for all problems, and also including Industry 4.0. But personally, I believe that we are going to see a coexistence of these technologies. I believe that we are going to see lots of efforts on putting together solutions that can incorporate, for example, gateways that can take in account that a large company has equipment with different radio technologies, and then lots of investments are going to be made on making this coexistence work. And Professor Kleber already talked about his research and also some of the efforts in standardization bodies. But I believe that we are going to see much more regarding standards for coexistence.
Thank you.
Well, I agree with Professor Aldebarro. First of all, I think 3GPP wants to conquer the world, but they need to know that there are other players. And I believe that this direction of coexistence is the one that we will have to face. Actually, we are working with this, and we believe this is the right direction. And I think actually that 3GPP created something that is bigger than they can foresee, which is the softwareization right in the heart of the technology. So you can change a lot of things, integrate a lot of things in the core. So they, in some sense, they do not control that anymore. So they want or they do not want will go in this direction. I think so.
Sure.
Yeah, this is GP. So I agree both of them in terms of coexistence of the network. If you look at Wi-Fi, it's a public network, right? So from manufacturing point of view, I think it's a data security had the highest concern for most of the manufacturers, and right now in US we have seen the movements of moving offshore company back to onshore, and so what we see here is happening. You will see is the entire supply chain, the ecosystem will be reestablished. And so the data connection between different small and medium-sized company and to ensure the security, I think a 5G will play a major role. That's my personal thinking. And as the earlier presentation, you could have a private network with a 5G, right? So, and basically you could have edge intelligence without having all the data send it to cloud, right? So I do see this is the 5G is really open up some of the area to really foster the growth and for promoting secure collaborations.
Thank you, Professor. We have one question for YouTube. The Professor Antônio Carlos de Oliveira Jr. from UFG. He has two questions. The first one, how the government, for example, telecommunication agents, will build and or management spectrum of private, no public 5G networks? And the second question, can you please provide the many topical challenges for the students, the PhD and master students who are looking this field, Industry 4.0 and 5G?
I think it's polite if I allow one of my colleagues to answer first, right? So I believe Kleber or Professor Lee may be the first this time. Just a suggestion.
All right, I can start, and then in the next round, Professor Lee starts. And well, the first question, I believe that it depends on the country. Unfortunately, Brazil is quite slow in this standardization and this legal stuff. In other countries, we see something very different. For example, the initiative of CBRS in US and similar stuff happening in China and Korea. So unfortunately, this is a very fragmented topic, and unfortunately in Brazil, we need to evolve a lot. I hope this changes in the soon future. And concerning the second question, I believe that there are very different approach here. I'll talk of some related more to software, of course. I believe that the core itself needs to evolve in different directions. I think we need to add more intelligence to the core. There are some initiatives mainly related to network autonomous, enhanced network autonomicity, but it's necessary to improve that part even more. And of course, the integration with IoT is something that opens a lot of opportunities in research.
Thank you. Professor Lee, please.
Yes, I agree. I think it's in terms of second question about the research topic, the integration, as I presented, is a human-centric wireless network, right? So the IoT combining with the human 5 sense and common sense, and using the 5G as a way to really create the ecosystem, allow information flow, allow the intelligence to really act on the needed solutions. Right, so I think that is a good research topic area. And also, even though US now is with the new president-elect, the globalization, it seems to me, is not going to stop, right? So it's going to change the agenda. So I do see the international collaboration in just a 5G area, right? And manufacturing 5G, it could be a good topic, and see how we can promote international collaboration. And because every country has their own product and their own needs, and how do we really share the resources as a way to have a sustainable growth? I think that is a topic also good for the international collaboration. And regarding the first one, as I'm not familiar with Brazil's this area, so I wouldn't make intelligent comments.
Thank you.
Yes, taking then the first question, I believe that there are going to be some efforts on unlicensed spectrum also. So people are going to be able to use 3GPP technologies for unlicensed spectrum. We are going to see, for example, millimeter waves and other high frequency bands being used without the needs of a license in future. And regarding the spectrum that requires a license, I can see that Anatel, that's our Brazilian regulator, is making efforts to open up spectrum and also to offer, let's say, spectrum as known in a cognitive kind of radio approach, in the sense that you have a primary user and you have also the secondary user. So whenever you note that the spectrum is not used by a primary user, then you can use that spectrum. So these are opportunities for factories and also, for example, mining facilities, people that are far from the big cities. They have lots of spectrum. We know about it. And we can see that Brazil has recently changed this legislation to, let's say, promote digital inclusion. And as Professor Kleber mentioned, our steps are slow, but you can see some movements in this area. So I believe that we are going to make a better job with respect to spectrum regulation. And regarding master's and PhD topics, I would say that artificial intelligence is one important venue for new directions and also something good for someone that's working, for example, in computer science or computer engineering. But I think that especially the vertical markets, for example, whenever you have the condition, let's say you are a Unicinos student participating with us here, and you are, let's say, working or you are close to a vertical specific markets, such that you know that, for example, that environment can be improved, that you know a specific tool can help a worker to do a better job. And as Professor Lee said, human must be the center of our attention. And so if you do research, or even if you are an entrepreneur and you open a startup company, so I believe that many new ideas are going to come up when people combine artificial intelligence, connectivity, 5G connectivity, or related techniques together with these vertical markets.
Thank you, Adebarros. Other questions? I have one question, comments. We have many opportunities, for example, considering the different perspectives, for example, the 5G and the Industry 4.0, considering both, but we have many challenges too. For example, we need integrate the peoples, for example, the expertise for the telecommunication expertise and the peoples for the IL, the technology, the information expertise. But we need to put the peoples in same room for develop different innovation solutions. But it's not easy. What opinion about this, please? Now you start for Professor Lee for turn around.
Thank you. So this is an excellent question. So in our university, this is a so-called interdisciplinary research topic. It involves multiple disciplines from computer science, the data science for the AI and wireless communications and the sensor technology, right? And then at the same time, you have to really deal with the users' acceptance of the solution. So we have a social scientist involved in the discussion. So, and this is not an easy task, right? So the institute I'm directing, we do have a faculty from all different disciplines, and we bring them together and try to highlight what is the most urgent need in our society. So that's why when I present as a smart manufacturing for sustainable growth, right? So this is the vision we see is for our planet. We have to do something, and how we can use the technology in a way to support each other, to harmonize the solution, right? So I think it's once we have a bigger goal, instead of sitting in a silo, then we can find a communication language, right? So, and then we can partition the system problem into different disciplines and see how we can have a cross-cutting way to communicate that. So this is the way we typically do, and we have so many faculty from different disciplines. I know at the beginning it's so hard, but once you started, everyone can see is, wow, this is a solution. It's going to change the world, going to transform the way we do work. And our work now suddenly has a value, right? It's going to change the world. So everyone become motivated. At the beginning, it's very hard. But once you get onto the journey, it's going to happen.
Thank you. Professor Adebarros.
Yeah, I like this question because I've been teaching for, I don't know, more than 20 years. And what I see is that we need to move fast, like as educators. We need to change the curriculum. We need to really update the way we teach. My father is an engineer, and when I was a kid, he was showing how they calculate things taking logarithms, basically because they didn't have any electronic calculator. And then today, sometimes I see people teaching things that are not needed anymore because we have computers. At the same time, if you take a conventional telecommunication class, people are not learning how to program, for example. They don't know about Linux. They don't know about embedded systems. And the key point for universities that are trying to teach and finish in 4 years or even less the complete, let's say, curriculum for a new professional. The challenge that we need to talk, as Professor Lee emphasized, among us, and then change the way we teach such that we can keep up with the pace of evolution, such that someone that's, let's say, graduating in near future, they are, let's say, capable of really looking at the technology and then coming up with ideas that combine, for example, not only artificial intelligence, but also communication technology, electronics and embedded systems, embedded Linux, and so on. It's a big challenge, and I believe it's not only for us, the educators, but also for the students themselves. They cannot stop and say, okay, now I have my degree. They have to continue to study, and I believe that this is not going to stop. I believe that that classical engineer or that classical lawyer or doctor, medical professional, they are going to have a much more fuzzy boundary between knowledge, and we are going to see a biomedical engineer doing something very close to what a doctor today does. So I believe it's a challenge to all of us.
Thank you. Kleber, please.
Okay, first of all, it's a very good question, Cristiano, and a very difficult one. I think that Professor Lee and Professor Aldebarro present very great point of views. I agree completely. I think that part of the solution is establish, as Professor Lee said, a goal, a larger goal in which lots of people must get together in order to solve that problem. And there are lots of problems in this direction nowadays in our society. And the second thing is we need to embrace this challenge, as Professor Aldebarro said. And I think actually this is more difficult for us, as I see in these new generations. For them, they are more open to deal with different areas. Actually, most of them are even motivated to work with different topics. In the beginning, they face some fear because there are a lot of new things, but they have open mind, and I believe that for the next generation, what we think that is quite difficult maybe will be easier. Maybe we are getting older, and we think that we have difficult to face this new challenge.
Okay, thank you. Professor George has one comment, one question. Please, Professor George. George, can you read?
Hello. Yes, but I put in the Teams. I don't know if you see. I would like to congratulations to the speakers and thank you for the great presentations and thank you, Professor Lee, for visiting us here in virtual in Unicinos. It's an honor to receive you with us, and I'd like to ask about what he thinks about the impact of the 5G and IoT and technologies 4.0 in human well-being. He told us about a very important idea related with that the human is the center of our attention when we are talking about the technology, but specifically in Industry 4.0, if you have fast-speed networks and great advanced infrastructure, and do you believe that, I think it's the most important aspect, if your artificial intelligence research will be enough and will support advanced in the same step to allow a well-being smart worker based on interfaces and filter information? Because I think one of the most important questions that we have now is if all the infrastructure that we are creating will alone we create an environment to support the well-being in the workers in the industry and the workers in all parts of our society.
Professor Lee, please.
Yeah, as I mentioned earlier, I think a human is so far, to my knowledge, there's no AI could perform the contextual awareness. AI is very good at the content. It's all the big data, machine learning, right? So, adaptive learning and so on. It requires a large set of data, but when you have a minimum set of data, and that requires the common sense. And human has really developed this a contextual way of visualizing the informations, right? So I think that is not replaceable at this time because you really need to know the past and what is the future and the aware of your current states, right? So a machine typical is a program by us, right? So program by us is giving a set of rules so it can evolve, right? But when we think about the environmental issues, and how do we define the greenhouse gas emission, and it's 100 years from now the impact, and what is, and that kind of information is really not really, although they are paper published and you can do the model, those is based on expert information, right? So I think it's using the 5G, we can really leverage the content information from the environments, from the things, from the machine, and have that data, then human can really inject their common sense to bring that content into context. And then I think as a human and machine can evolve, and environment can evolve together to harmonize human, machine, and environments. I think it's going to be a fuse in a way, and I don't think we will be really outfitted by robots.
There is.
Thank you. Thank you.
Thank you very much.
We don't have more time, but I would like to more one around about the last message. Please, Professor Aldebarro, can you, what message for this panel, for your opinion?
I think that we are for sure looking at a new way of doing things, and I believe that I'll steal the message that Professor Lee shared with us regarding the need to build a happy working environment and so on. I think that all of us who are interested in technology, we are going to continue study 5G, Industry 4.0, but I believe this is a very good message to take home, that we need to work to build a better society.
Thank you very much. Kleber, what's your message in these 2 hours?
I think I will enjoy the point that Aldebarro started. I think as in smart city, what is a smart city? Smart city actually is to make the people better, make the life of the people better. And I think that the Industry 4.0 must also be an opportunity not to make the things efficient. Of course that we are searching for that, but we are also interested in make the environment safer, make the environment more appropriate for human beings. I think we must always have this target at mind. It doesn't matter how important are the technology involved, but in the end of the day, what really matters are the human beings.
Thank you very much. And Professor Lee, what's your message in this panel, in your opinion?
Yeah, my message is this is really a great forum for discussion of the 5G's future impact, and it tells us our society is moving into this new agenda in connecting with all of us, and not only with a limited bandwidth using at the fixed place. It's really a mobilely connecting all of us. And I believe the whole world need to be connected and share the same message, and how to really deal with the issue the whole planet is facing. And by bringing the smart manufacturing empowered by the 5G, I think we can really solve the problem to have a sustainable growth and also safe environments, and also we can solve the climate change problems.
Thank you very much. We don't have more time, sorry. In my opinion, the panel is excellent. The discussion is very nice. Thank you for our speakers. Thank you for Aldebaros, Professor Kleber, Professor Lee. It's a fantastic moment, and I hope to see you at other opportunities. Thank you very much. And I return the token for Professor Righi. Thank you for the opportunity.
Thank you. Thanks, Professor Cristiano, for conducting the panel. So I am very happy for this high quality of the panel. It was really a lecture for us in terms of content, in terms of research, right? Well, I am confident that we will have a good way to follow together in terms of research in the future, in terms of projects, right? And so, as one of the coordinators of the forum in this moment, as I said, thank you, Professor Cristiano. Thanks our speakers, Professor J.P. Lee, Professor Kleber, Professor Aldebaro. And I would like to also thank our backstage staff, right? And thanks also the audience from YouTube. So in this moment, unfortunately, because also I had questions and it was a great discussion, right? But I must close our section. It was a pleasure for me. It was a pleasure for the Unicinos team. It was a great moment for the 80th edition of the Brazil-Korean Forum. Thank you all for attending this panel. Bye-bye.
Thank you. Bye-bye. Take care.